Hello everyone, this is Dr. G. Karthik Reddy working as Associate Professor in the Department of EC, MLR Institute of Technology, Hyderabad. And today's session topic is Stationery Random Process. Stationery Random Process. And today's content are what is stationary process, what is first order stationary process, what is second order stationary process. Stationary process. First we will discuss the definition. What is the stationary process? Okay, random process is said to be stationary if all the statistical properties such as mean, movements, variance does not change with time. Okay, does not change with time. Okay, if you are considering all the statistical properties means we already discussed in the previous lecture that it may be either expectation or mean, or all the movements may be up to nth order movements. Okay, in that only you are going to get mean square value, variance, okay, and whatever we discuss, Q, squareness. Okay, all the movements, all nth order movements, okay, all does not change with the time. Does not change with time, then we are calling that as stationary process. Okay, all this, whatever we are considering, all these movements are always depending upon what? Density function. Then what you have to become? The stationary, always it must be depending on density function. Okay, density function we already discussed in the first order, second order. Okay, fx of x represents, this is a first order. Next, fx of x comma t. Okay, fx of x1 comma x2 comma t1 comma t2. This becomes second order. Okay, we discuss first order and second order density functions. Okay, we are discussing based on this. We are having the first order stationary process, second order stationary process. Okay, we are discussing that first order and second order stationary process. Now first we will discuss the first order stationary process. Okay, the order of the density function is first order. Okay, the first order density function. Okay, what is the first order density function? A random process is said to be stationary to order 1 or first order stationary if its first order density function does not change with time or shift in time value. Okay, this is the definition of that. Okay, you are considering only the first order density function. Okay, if x of t is a random process. Okay, x of t is a random process which is first order stationary process. Okay, if this condition is satisfying, means fx of x1 comma t1 must be equal to fx of x1 comma t1 plus change of t. Okay, change of t. Okay, we can also denote this as tau. Okay, you can also denote this as tau, or we can write this as fx of x1 comma t1 plus tau, or in some other notation we can also write fx of t1 comma t2 also we can write. Okay, where t2 is equal to what? T2 is equal to t1 plus tau. Okay, here what is telling that the density function for the instant t1. Okay, density function for the instant t1 and next for the instant t2. Okay, if the density function must not be changed. Okay, if the density function is not changing. Okay, the density function is not changing for a particular random process x of t, then the condition is satisfying. That condition is called first order stationary process. In the first order stationary process, okay, what are the formulas you are having in the first order stationary process? Okay, because it is depending only on particular random process, okay, or a particular density function. Okay, we are having the definition, that is expectation. Okay, expectation of x of t. Just now we have discussed expectation of x of t, x bar. Okay, x bar of t, which is equal to integral minus infinity to infinity x into fx of x comma t dx. Okay, you are having only the first order density function. Okay, only the expectation is applicable. Even the mean square is also applicable. Okay, expectation of x square of t, x bar of t. Here also you have integration minus infinity infinity x square into fx of x comma t dx. Okay, this is the mean square value. This is a mean square value. This is a mean value. Okay. So likewise, but here first order stationary, we are majorly concentrating on mean. Okay. Mean must be constant. Okay. Mean must be constant. Okay. When what happens when there is no change in time, the expectation becomes the constant value. Means the expectation of x of t becomes just expectation only x bar. That is a what you are having. That is a random variable only you are going to get, because when it is not having any change in time, because mean value must be constant at time, any time instant, that becomes what? Expectation of random process becomes random variable of the expectation only. The random variable of the expectation is always constant only. This condition is what? Expectation of random process is constant is for the first order stationary process. Now next, second order stationary process. Second order means, okay, stationary process is depending on what is that? Density function. Means you have to get second order. Second order density function means you have to get fx of x1 comma x2 semicolon t1 comma t2. Okay, whatever they are having, it must not be changed. Means fx of x1 comma x2, t1 with some change of delay, next t2 with some change of delay. Okay, change of delay. Now here, that is the definition. Okay, that is the definition of second order stationary process. A random process is said to be stationary to order 2 or second order stationary if it's second order joint density function. If you are having more than one, okay, more than one variable, then we are considering that as joint. Okay, you are having two variable, joint density function does not change with the time or shift in time value. Okay, does not change with the time or shift in time value. It is a function of time difference. Okay, it is a function of time difference because it is difference of time only. Okay, difference of and not absolute time. Means here he is telling that it is depending upon the shift in time, not the absolute time t. Note that second order stationary process is also a first order stationary process. Okay, if you are considering only the t1, okay, you are having first part, you are having first order stationary. t2, if you are considering this part is 0, then you are having only the first part. Okay, then it is also valid for the first order stationary process. And or second order stationary process. Okay, second order stationary process means what is applicable? The correlation concept is applicable. Here we are considering only the x of t. Only x of t if you are considering, then what you are going to get? Autocorrelation function. Means here autocorrelation function is also depending on time differences, but not on absolute time. But not on absolute time. It is denoted as Rxx of t1 comma t2, which is equal to expectation of x of t1, next x of t2. Okay, we can further modify this one. Let us assume that t1 equal to t and t2 equal to t plus tau. Okay, t plus tau. Then what you are going to get? Expectation of x of t plus tau. Okay, this is the definition of autocorrelation function. This is the definition of autocorrelation. Whenever the term stationary process comes, okay, here it is independent of time t and it is depending upon time shift. Okay, autocorrelation function is dependent on time shift, that is tau is equal to t2 minus t1. Okay, this is the formula for the notation. Rxx of t1 plus tau is equal to expectation of x of t1 into x of t1 plus tau, and it should be independent of time t. This condition is very important. Rxx of tau must be independent of time t, and but it is depending upon absolute time. Okay, absolute time, it is independent of absolute time and it is depending upon time shift. Okay, in today's session we have discussed, okay, first order stationary process, definition of stationary and second order stationary process.